Hello students, this is Professor Chalai, and in this lecture we'll talk about dimensional analysis and unit conversions. In chemistry, and in fact all of science and engineering, we deal with lots of numbers. However, these numbers by themselves are meaningless. We don't just deal with, for example, 36. 36 what? It may be 36 milliliters, which tells us that the number represents an amount of volume, perhaps of a solution. The milliliters are the units or dimensions of the number. In dimensional analysis, we can treat the units the same way we treat numbers. We can multiply or divide them. For example, you might measure the length and width of a surface to be 1.20 and 0.80 meters respectively. What is the area? Well, we can just multiply the length and the width. What about the units for the area? Similarly, we can multiply the units of the length and the width. In this case, it's meters multiplied by meters to get meters squared. Dimensional analysis can be a powerful problem-solving tool in chemistry. Let's look at a simple example of how we can use this technique for unit conversions. Let's say you have 2 apples, but you really want grapes. You go to the market where each merchant is trading only one kind of fruit. The grape merchant only accepts cherries for trade, and he will trade 1.2 cherries for 2 grapes. The cherry merchant will trade 1 banana for 5 cherries. And the banana merchant will trade 2 apples for 3.5 bananas. In this example, the apples, bananas, cherries, and grapes are the units. Trading one fruit for another is the same as converting from one unit to another. If you trade your apples for bananas, then your bananas for cherries, then your cherries for grapes, how much grapes will you end up with? Well, since 2 apples are equal to 3.5 bananas, if we divide one by the other, we will get 1 as the answer. It doesn't matter which is the numerator and which is the denominator. And if we multiply by 1, we're not changing the value of the fruits that we already have. We're just changing the type of fruit. In other words, we're not changing the amount of things we have, we're just changing the units. We do need to make sure that the apple goes on the bottom to cancel out the apples we already have. If we do the math, we'll find that we end up with 3.5 bananas. Similarly, we can then trade our bananas for cherries. Make sure that our bananas cancel, and we end up with 17.5 cherries. Finally, we trade our cherries for grapes. And if you've just punched these numbers into our calculator, we end up with about 29 grapes. Using a more realistic example, let's say you measured the length of a pencil to be about 3.50 inches. However, because we're chemists, we need to express this length in SI units, in meters. We should know that 1 inch is equal to 2.54 centimeters exactly. We can use that information to convert inches to centimeters. We should also know that 100 centimeters is equal to 1 meter, which we can use to now convert from centimeters to meters. Once we set up the problem and have all the units cancel out, we just need to punch the numbers into our calculator, and we find that 3.50 inches is 0.0889 meters. Answer to 3 significant figures. Let's look at a more complex example. Let's say you found the density of some object to be 1 pound per cubic feet. However, you want to convert this to grams per cubic centimeters, which is more commonly used in chemistry. For a complex problem like this, let's deal with the units one at a time. First, we'll deal with the mass unit, pound, and try to convert that to grams. We know that 1 kilogram is 2.205 pounds. So we can use this information to convert pounds to kilograms. And we should know that 1 kilogram is 1,000 grams, which we can use to convert the mass to grams. Now for the volume units, where we need to convert cubic feet to cubic centimeters. We know that 1 foot is 12 inches, which is all good, but we need cubic feet to cubic inches. Well, dimensional analysis tells us that whatever we do with numbers, we can also do with units. So let's cube everything. That should give us cubic feet, which cancels out nicely, and leaves us with cubic inches. We can now convert to cubic centimeters by remembering that 1 inch is exactly 2.54 centimeters. Once again, we need to make sure that we cube everything to get cubic inches to cancel out. Now we're left with cubic centimeters in the denominator. The final step in such a problem is just to punch all these numbers into a calculator, and we end up with 0.016 grams per cubic centimeter to two significant figures. To summarize, in this video, we looked at units and dimensional analysis, and how we can use this technique to convert units in chemistry. There's a wide range of problems you can solve in chemistry just by using dimensional analysis. And so it's a technique that I really recommend you practice thoroughly. I'll see you all in the next lecture.